We are standing right at the edge of a massive shift in artificial intelligence, and really it all boils down to just one huge question.
You know that question? It's pretty much been the holy grail for AI researchers for years. And now it looks like Google's brand new model, Gemini 3.1 Pro, is finally giving us a real peek at an answer. The big headline here, the thing you really need to know, is that it's more than doubled its performance on a super important reasoning test. This isn't just a small step, it's a huge signal that what AI can do is fundamentally changing.
Okay, hold on. To really get why this is such a game changer, we kind of need to rewind a bit. Why has real reasoning been so incredibly hard for AI to crack up to this point? What was the actual wall they kept hitting?
Yeah, that's a great question. The best way to think about it is like this. Older AI models were like these super smart librarians. I mean, they were amazing at finding and summarizing any book you asked for, but they could never ever write a new book themselves. So when you gave them a problem they hadn't seen before, a totally novel challenge, they would just stall out. They'd misunderstand what you were really asking, get trapped in these weird repetitive loops, and just fail. Why? Because they lacked that spark of genuine algorithmic creativity.
Okay, so this is where Gemini 3.1 Pro enters the picture. What was the secret sauce? What did Google's engineers actually do to finally smash through that wall?
It really all comes down to one number, 77.1%. That's Gemini 3.1 Pro's score on this really critical reasoning test called ARC AGI 2. And let me be absolutely clear here. This isn't just a tiny step up. We're talking more than double the score of the model that came right before it. This isn't an incremental update, it's a massive, fundamental leap in what these things can do. And what's so cool about this is what that test actually measures. See, ARC AGI 2 isn't some glorified trivia game. It's not about spitting back facts it memorized from the internet. No, it forces the AI to solve these weird visual logic puzzles it has never seen before. It has to figure out the hidden rules all on its own right there on the spot. It's basically a pure test of abstract problem solving, which, well, that's the heart of what real reasoning actually is.
All right, so a high score is great, I get it, but what does that actually mean for us? What can we do with this new reasoning power? What can it build in the real world, right? This is where it gets really exciting. Where the theory hits the pavement, this abstract reasoning power unlocks things that were just pipe dreams before. For example, the model can chew through an entire hour of video or a 900-page document in one go. But here's the bigger deal. It's not just analyzing stuff anymore. It's actively building things. We're talking about generating the code for animated graphics or even prototyping interactive 3D structures just from a simple text prompt.
So it sounds like we're way beyond just building a smarter chatbot here. I keep hearing this phrase agentic AI popping up everywhere when people talk about these new models. Can you just break that down for us? What is that?
Exactly right. Agentic AI is all about a fundamental shift. We're moving away from AI as a passive tool that just answers questions to an active partner that goes out and gets things done. So you don't just ask it, what is the orbit of the ISS? Instead, you give it a complex goal, like, hey, build me a live dashboard that actually visualizes the International Space Station's orbit in real time. And then the agent just goes and does it. It's a system that can create a plan, use tools like code, and run a whole sequence of steps all on its own to make it happen.
And if you look under the hood, here's how that whole process plays out. First, the agent takes your big goal and breaks it down into tiny, bite-sized tasks. Next, it comes up with a multi-step plan, a strategy. Then comes the action part. It starts executing code, making calls to different APIs and tools. And finally, it pulls all those little results together into one finished product. And the tools that make this all possible, the engines for developers, are platforms like Google's Vertex AI and the Gemini API. That's where you build these things.
Okay, but let's be real. Google isn't the only player in this game. You've got absolute powerhouses like Anthropic and OpenAI in the ring too. So how does Gemini's new reasoning power really stack up against the competition?
All right, let's get into the numbers, because this is where the story gets really interesting and a little complicated. When you look at pure abstract reasoning, that ARC AGI 2 test we talked about, Gemini 3.1 Pro is the undisputed king of the hill. It's way out in front. But the race is getting super specialized. If you need an AI to actually execute tasks inside a live coding environment, well, a GPT Codex model is still the champ there. And if you're talking about high-level strategic business planning, Anthropic's Claude Opus has a pretty big lead. So the takeaway here isn't that there's one model to rule them all. Nope, we're seeing a whole field of specialized champions, each one best at its own thing.
So really, it all just boils down to picking the right tool for the job. You pick Gemini 3.1 Pro if you're tackling a thorny algorithmic problem, doing deep scientific computation, or analyzing huge amounts of video or documents. Plus, it's cheaper, which is a big deal. But if your main goal is to map out a complex business strategy, or to automate really sophisticated coding pipelines, then yeah, you're probably still going to lean on Claude or one of the specialized GPT models. They still own those niches.
Okay, so let's zoom out. We have this future with all these specialized, super smart AI agents. What does that actually mean for the people who are going to be using them every day? I'm talking about the developers, the scientists, the engineers in the trenches. It means we can finally start to unstick problems that have been stuck for years. I mean, check out this quote from Andrew Carr. He's the co-founder of a company called Cartwheel. It's a perfect example.
They had this really nasty, long-standing bug in their 3D animation pipeline. It was a spatial logic thing, basically something that completely baffled other AI models. They threw Gemini 3.1 Pro at it, and because of its advanced reasoning, it was able to get to the root of the problem and just fix it. That is precisely the kind of tough, real-world engineering problem these new AIs are designed to crack.
And here's the best part, especially for any developers listening right now, you can start playing with this stuff today. It's not some far-off future tech. The tools are live. You can hop into Google AI Studio and start prototyping. You can mess around with generating those animated SVG graphics we were talking about, or you can even try your hand at building one of those agentic dashboards that pulls in live data. You can get to the model through the Gemini API, through Vertex AI if you're doing something big, or even right from your command line. It's all there. Okay, so as we wrap this all up, if people are going to remember just 3 things from our conversation, what should they be? Okay, 3 big things. Number 1, abstract reasoning is the next great frontier in AI. We're moving past simple pattern matching and into genuine problem solving. Number 2, this new reasoning is unlocking agentic workflows. Think AI that can manage a complex project from beginning to end all by itself. And number 3, this insane competition between the big players, it's amazing for all of us. It means better, more specialized, and more powerful AI tools are going to be coming at us faster than we can imagine.
Exactly. And this whole leap forward really leaves us with one massive question to chew on. For so long, our progress has been held back by the limits of our tools. But now we have an AI that can actually reason its way through brand new, complex problems. So the question for all of us is, what are the first hard problems we should ask it to solve? What are those scientific mysteries or engineering roadblocks that seemed impossible just last year that might now be within our grasp?